Go. Hi, everybody. So today we did our math lesson. So we're going to spend a couple minutes going over everything we did in math in case you missed our class today. So we're going to look at our application problem first, and then we're going to go into the lesson of adding today. So as you see in front of me, I have our wonderful application problem. I'm going to read it for you, and then I'm going to show you the methods that we use as a classroom this year to solve this problem. You're more than welcome to pause this right now and do this with your scholar at home. But this is our application problem. Normally, beginning of every math lesson, we do a problem. It's kind of like a warm-up into math. There are 134 pencils in the drawer. Keith placed 127 more pencils in the drawer. How many pencils are there in all? So we normally answer things using a RDW method. And what an RDW method is R stands for read it, D stands for draw it, and W means we're going to write it. It's very important that the kids understand how to read it. They understand how to draw the problem out, and then they put the answer in a sentence form. So the first things first, one more time. There are 134 pencils in the drawer. Keith placed 127 more pencils in the drawer. How many pencils are there in all? So 134 pencils is my first big information, so I'm going to pull that information out. Then 127 more pencils. That's super important too. Not only just that, but the word more pencils as well. More is telling me that a number is rising somewhere in our question. And then it says, how many pencils are there in all? And your scholars should know that in all means addition. So we're going to add these problems up. You can add them a couple different ways, but we talked about there's a vertical method where you could do 134 plus 127, and we know that 4 plus 7 is 11. 3 plus 1 is 4, plus 2 is 6, and then 1 plus 1 is 2. But the method we're going to show you right now is a method we're going to look into just a little bit deeper, and that is using our place value method. So what that means is we're going to be looking at adding this problem using a place value. So we're going to need 3 charts. The reason why we have 3 is as you see above, we have 3 numbers. And if we were to put a divide between them, you know you have a number in each area. So I know I have a 4 in the ones place, so that's going to be 1, 2, 3, 4. I have a 3 in the tens place, so that's a 1, 2, and a 3, and that's a 1 in the hundredths place. I'm going to skip a line, and I'm going to do my second problem down below. So I have a 7 in that ones place up there, so I'm going to put a 7 down below. I have a 2 in the tens place, and then I have a 1 in the hundredths place. And now it's as simple as counting your dots. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Uh-oh. You can't have more than 10 ones, so that means I'm going to have to circle that 10, and that 10 is going to move over to your tens place. That leaves me with 1 dot left. And then in the tens place, you just count your tens. 1, 2, 3, 4, 5, 6. And then in the hundreds, you have 2. So my answer was 261. So Keith has 261 pencils in his drawer. So we're going to spend a couple minutes talking about this method. We're going to go over a couple problems, and then I'm going to give you a list of problems you could do at home with your child. So if I had the problem 121 plus 129, how would that look? Well, I have 3 numbers in each number set. By the way, this is called a number sentence. So I know I need a hundreds, a tens, and a ones. And then just like we did before, we're going to take each number and we're going to write them in our problem. And you can also match them up if you want to actually label your numbers as well. So I have 1, 1, I have 2 tens, and I have 100. Skip a line down here. Look at your next number. I have 9 ones. I have 2 tens, and I again have 100. So we're going to add them up. 9 and 1 make 10. So we circle this number, and we're going to draw it over. And we're going to put that right where we put it. I've taught my kiddos that when you draw your arrow, you put that dot at the end of that arrow to show where that dot went. So that leaves 0 ones left. And then you have 1, 2, 3, 4, 5. And then you have 2 hundreds. So 121 plus 129 equals 250. This works all the way up to even if you have super big, hard numbers. Let's look at this problem, for instance. Let's look at the problem 5,638 plus 3,789. Well, I have 4 numbers, so that means I need 4 groups. So we need to label our numbers. Ones, tens, hundreds, and that 5 is in the thousands place. So we're going to go ahead and make that number and make those numbers out. So we have a TH for 1,000. We have an H for 100. We have a T for 10. And we have a 0 or an O for ones place. By the way, this is also why it's called the place value method, because we're looking at each place value when we add. Now we're going to take our number and we're going to put it into dots into our number form or place value chart. So I have 8 in the ones place. I have a 3 in the tens place. I have 6 in the hundreds place. And I have 5 in the thousands place. Also, notice how nice and neat I'm doing this. That's very important if you work with your child to help make sure that when they're doing this, it's nice and neat. The reason for that is because very often Ms. Jennings and I see dots that are being put into the chart every which kind of direction. And it's really important that we see the separation between the numbers so that we know our dots match the number that we have. It is it happens very often that scholars will get these wrong, and that only happens if they mess up on their dots. Because in the end, all you want them to do is count the dots. It's a very safe way of adding. If you look at your second number, I have a 9 in the ones place. 4, 5, 6, 7, 8, 9. Notice how I just went ahead and put that 9 out here. I didn't have to make a third row, and I'm not putting it up higher. I'm keeping it in line with my numbers. Next, I have an 8 in the tens place. So 1, 2, 3, 4, 5, 6, 7, 8. That one went a little bit lower, but still in a really good position. I have a 7 here. So 1, 2, 3, 4, 5, 6, 7. And then we have a 3 in the thousands place. And the reason why we're jumping from a number that's super small to a number that's super big is because I want you to see that it doesn't matter what number you have, it all works the same. I have 8 right here. I need 10 total. So 8 and then these two make 10. So that 10 is going to go right next door. So then that leaves us with 1, 2, 3, 4, 5, 6, 7 remaining. Then we can go to my tens place, and we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Up, we have a 10. We circle our 10, and that 10 comes right next door. That leaves me with 2 left over. Then we go to our hundreds place, and we can count our hundreds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that comes right next door. Notice how I moved my 10 over immediately before finishing counting. It's very important, especially for scholars, to know that once they find that 10, they move it immediately to stop any kind of misconceptions. Very often, we'll see kids circle the 10 and then forget to move it over because they're finishing their counting. So once they circle it, they move it. Then you can come back and finish it. I have 1, 2, 3, 4 left over. And now I can count my thousands place. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I know my answer is going to be 9,427. If you like to do more problems with your child, you may stop the video now and you may work on these 4 extra problems with them. Thank you so much for spending the time right now watching us and listening to us with the lesson that we did today. It's always a pleasure to have you on our classrooms, and Miss Jennings and I and Miss Winter look forward to seeing y'all tomorrow. All right, bye.
All right.